Hello students, let us start with the next chapter, that is chapter 14, electric current and its effects. In this chapter, we will learn about symbols of electric components, heating effect of electric current, magnetic effect of electric current, electromagnet and electric bell. Before we learn about the effects of electric current, it is important that we understand the circuit and its symbols. We have already learned about circuits and its symbol in 6th grade. So let us just recall all these symbols. Electric cell is represented by two lines. The bigger line represents the positive terminal and the smaller one represents the negative terminal. We also have the symbol for electric bulb, switch off where the switch is not connected, switch on where it is connected. Battery is when two or more cells are joined together, and a simple line represents the wires. It is important that we use circuit symbols to represent the component of the circuit because these symbols are universal and they can be drawn very easily. So it becomes easy to draw a circuit using these symbols. If we look at an electric cell, then it has two terminals, positive and negative terminal. The positive terminal is represented by the longer line and the negative terminal is represented by a shorter line. If we join two or more cells together, then we have batteries. In a battery, the positive terminal of one cell is connected to a negative terminal of another cell. It is very important that we connect this correctly because if we don't, then the circuit does not work. If we look at a simple electric circuit, then it can be made using a cell, an electric bulb, switch and wires. The bulb glows only when the switch is on and the circuit is closed because we need to understand that the current cannot travel through air. So if we were to represent this circuit with the help of symbols, then we will do that as shown in the diagram where the closed circuit has the switch on. So you can see that there are no gaps in this closed circuit, whereas the open circuit has switch off. So we can see a gap in the circuit. So the bulb glows when the switch is on because there are no gaps, whereas the bulb does not glow when the switch is off because there is a gap in the circuit. Now let us try to understand about heating effect of electric current. When electric current flows through a wire, the wire gets heated because of the charges that are passing through it. Because the wire gets heated, if we touch any component of the circuit, then we feel the heat is radiated off it. This is called the heating effect of electric current. We can perform an activity to show the heating effect of electric current. We have to take two nails and attach a nichrome wire between them. We have to connect it with a cell and a switch. Now, when we turn the switch on, then there is no gap. So electric current flows through the circuit. At this time, if we touch the wire, then the wire gets heated. Whereas if we turn the switch off, then there is no current in the circuit. And this time, if we touch the wire, then the wire is not heated. So this shows the heating effect of electric current. We use this heating effect of electric current in our day-to-day life in various devices like electric heater, room heaters, electric kettle and hair dryers. An electric bulb is used for light, but it also gives off heat. Now this is not something that we want. We want the bulb to only give us light. This results in wastage of electricity. So in order to reduce this, we have compact fluorescent lamps. These lamps reduce wastage and can be fixed in ordinary bulb holders. That is why we need to buy CFLs and look for an ISI mark in that. ISI stands for Bureau of Indian Standards. This mark ensures that our appliance is safe and the wastage of energy is minimum. We studied about the heating effect of electric current. The amount of heat produced depends on the material of the wire, the length of the wire, and the thickness that is used to make the wire. Wires made from some special materials melt quickly and break when large electric current are passed through them. These wires are used for making electric fuses. Electric fuse is a safety device used in electrical circuits which protects the electrical circuits and appliances and prevents fire, as the circuit breaks whenever the current is too large. Now let us study about the magnetic effect of electric current. When electric current flows through a wire, it behaves like a magnet and we observe some amount of deflection. This is called magnetic effect of electric current. Hans Christian Ørsted was the first person who noticed this deflection of compass needle every time the current was passed through a wire. We can perform an activity to demonstrate the magnetic effect of electric current. In this activity, we'll need a compass needle and we'll connect it to a cell, switch and a bulb. Now, every time that we pass electric currents and the switch is on, we notice deflection of the magnetic needle. Whereas when the switch is off, this deflection is not seen. So this shows the magnetic effect of electric current. We have all heard about electromagnets because they are used in almost all electrical devices nowadays. So let us understand what is an electromagnet. When electric current is passed through a coil of insulated wire wound around a piece of iron, this acts as a magnet. So this is basically an electromagnet. Whenever we pass current through it, it will act as a magnet. But when this is switched off, the magnetism goes away. So we can demonstrate this by doing an activity. Here we'll try to make an electromagnet. We'll take an iron nail and we'll wound a insulated wire around this nail. We'll connect it to a switch and a battery. Now whenever electric current is passed, the nail becomes a magnet, and to test this we can bring some pins near it. When the current is switched off, the nail loses its magnetism. Now let us try and understand the working of an electric bell. The electric bell is based on electromagnetism. It basically has a coil of wire around a piece of iron which acts as an electromagnet. There is a contact screw near the iron strip. So whenever we pass electric current through it, the iron strip is in contact with the screw, and when the current flows through the coil, it acts as an electromagnet. It then pulls the iron strip, and in this process, the hammer at the end of the strip strikes the gong of the bell to produce a sound. However, when electromagnet pulls the iron strip, it also breaks the circuit. The current through the coil stops flowing in this case. So now the coil is no longer an electromagnet. It no longer acts or attracts the iron strip. The iron strip will then come back to its original position and touches the contact screw again. So this again completes the circuit. The current flows in the coil and the hammer strikes the gong again. This process is repeated whenever we press the bell. Let us now summarize everything that we have learned in the chapter. So in this chapter, we started by learning various symbols that are used to make a circuit. We have studied the heating effect of electric current and how it is used in different appliances. We have studied about electric fuse, which prevents fires and damage to electrical appliances. We have also studied about magnetic effect of electric current, electromagnetism, and its applications. I hope you understood this chapter properly. Thank you.